Good day viewers, my name is Ode Godwin Daniel and I'll be your tutor for today. Please like, share and follow us across all social media pages at Gordon School of Mathematics. Please also click on the bell notification so that you get notified whenever we post educational videos on mathematics like this. Today, we'll be looking at the topic number-based system. Consider this sum, 2 plus 2 equal 4. Now, 2 plus 2 equal 4 is absolutely correct. However, what if I say 2 plus 2 equal 10 is also absolutely correct? Now, the difference between this sum and this sum is the number base in which the addition is carried out. Now, 2 plus 2 is equal 4 if and only if this sum is carried out in base 10. And then 2 plus 2 is also equal 10 if and only if this sum is carried out in base 4. So 2 base 4 plus 2 base 4 is equal to 10 base 4. And 2 base 10 plus 2 base 10 is equal to 4 base 10. Having said this, this goes to say that every of our mathematics that we know that that are being done from preparatory to nursery to primary to junior secondary school, senior secondary school, even up to university, all these mathematics are carried out in number-based system 10. So your addition, your subtraction, your multiplication, even division, simultaneous equation, quadratic equation, and so on and so forth. Now, they are all done in base 10. However, these mathematical operations can also be done in any other base system different from base 10. This being said, the number base 10 is our natural base. It's the natural base because it's the base in which every mathematics is carried out naturally. And that is why if you have 2 plus 2 equal to 4, because it's in the natural base, it's not compulsory that you write the base as a subscript of the number. However, if you are working under any other base apart from base 10, it's compulsory that you have to identify what base you are working or operating on. Now, that being said, today we will be looking at the topic listing the members of a base. Now, this will tell us how the numbers of each base are gotten. For example, we have base 10, which is our number, which is our what? Natural base. Now, first thing to note is this, is that the greatest number you can ever find in any base is 1 less than the base itself. The greatest number you can find in any base is 1 less than the base itself. So if we are looking at base 10, we know that the greatest number you can find in base 10 is 1 less than what? 10, which is the base. And 1 less than 10 is equal to what? 9. Now, if 1 less than 10 is equal to 9, it means the numbers which are the primary numbers in base 10 are the numbers from 0 to 9. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 is the greatest number that you can find in a base 10. How about base 9? Now we know that the greatest number that can be found in any base is 1 less than the base. So the greatest number that can be found in base 9 is 1 less than the base, which is what? 9. And 1 less than 9 is what? 8. So we know that the primary numbers that would exist in base 8 are, which are 0, 1, 2, 3, 4, 5, 6, 7, and 8. Now, the greatest number that you can find in a base 6, for example, is 1 less than the base itself, which is what? 6. And that is what? 5. Now, 1 less than 5, 1 less than 6 is 5. That means that the primary numbers that would exist in a base 6 are 0, 1, 2, 3, 4, and what? 5. Now, this being said, like I said, that our mathematics are carried out naturally in what? Base 10. Now in our preparatory class, while we are being taught the counting number, we know that the counting numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on and so forth. Which means that after the greatest number, which is 9 in base 10, there are other numbers after the greatest number. However, we know that the greatest number you can ever find in any base is 1 less than the base, which means the greatest number you can find in base 10 is 9. So now, how then did we come about 10, 11, 12, 14, and so on and so forth? Now, to get the other numbers in any base, we use a function called mapping. How do we perform mapping? So the first thing you need to do is to write out the primary numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, in mapping, in getting the other numbers, we map from the first non-zero digits. The first non-zero digit. The first non-zero digit means the first number that is not 0, and that is 1. So we start mapping from 1. We map 1 with every other numbers, every other primary number. Then we map 2 with every other primary numbers. We map 3 with every other primary numbers. We map 4 with every other primary numbers. We map 5, 6, 7, 8, and 9. Now let's start mapping 1. Mapping 1, like so, we just put 1 under. So I map 1 to 0, I get 10. Map 1 to 1, I get 11. Map 1 to 2, I get 12. Map 1 to 3, I get 13. Map 1 to 4, I get 14. Map 1 to 5, I get 15. Map 1 to 6, that gives me 1 and 6, which is 16. If I map 1 to 7, that gives me 1 and 7, which is 17. If I map 1 to 8, that gives me 1 and 8, which is 18. And I map 1 to 9, that gives me 1 and 9, which is what? 19. Having done that, we map 2. Mapping 2, of course, write out the primary numbers, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we are mapping 2. First, map 2 to 0. That will give you 2, 0, which is 2, 1, 20. You map 2 to 1, that will give you 2, 1, which is 21. Map 2 to 2, that gives you 2, 2, which is 22. You map 2 to 3, that gives you 2, 3, which is 23. You map 2 to 4, that gives you 2, 4, which is 24. Now you map 2 to 5, that gives you 2, 5, which is 25. Map 2 to 6, that gives you 2, 6, which is 26. You map 2 to 7, that gives you 2, 7, which is 27. Map 2 to 8, that gives you 2, 8, which is 28. And then you map 2 to 9, that gives you 2, 9. If you continue to map forward, you map 3. Mapping 3, we will get 30 to 39. Mapping 4, we will get 40 to 49. If you continue to map, mapping 5, you would get 50 to 59. Now mapping 6, we would get 60 to 69. When you map 7, we would get 70 to 79. Mapping 8, we would get 80 to 89. Mapping 9, we would get 90 to 99. The next number to map after mapping 9 will be 10, right? So we map 10. Mapping 10. Now, let's map 10. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the primary numbers, right? We are mapping 10. You map 10 to 0, you get 10, 0. You map 10 to 1, you get 10, 1, which is 1 and 1. You map 10 to 2, you get 10, 2. Or you map 10 to 3, you get 10, 3. you map 10 to 4, you get 10 4. You map 10 to 5, you get 10 5. When you map 10 to 6, you get 10 6. You map 10 to 7, you get 10 7. You map 10 to 8, you get 10 8. And then when you map 10 to 9, you get 10 9. And that is mapping 10 gives us the number 100 to 109. To get the number 110 to 119, you map 11. To get the number 120 to 121, 29, you map the number 12. To get the number 130 to 139, you map the number 13. To get numbers 140 to 149, you map the number 14. To get numbers 150 to 159, you map the number 15. To get numbers 300, for example, right, to 309, you map the number 30. And that is how numbers are gotten. You keep mapping, mapping, and mapping. Let's try getting the numbers in another base different from base 10. Let's say, for example, the number base 6. So, of course, we know that the greatest number or digit you can find in any base is 1 less than the base. So the primary numbers of base 6 are 1 which is less than 6, which is 5. And then they are what? 0, 1, 2, 3, and 4. 4 and 5 for base 6. Now, mapping 1, right? Write it as 0, 1, 2, 3, 4, and 5. Mapping 1. If you map 1 to 0, you get 1 0, which is 10. You map 1 to 1, you get 1 1, which is 11. You map 1 to 2, you get 1 2, which is 12. You map 1 to 3, you get 1 3, which is 13. Map 1 to 4, you get 1 4, which is 14. And then when you map 1 to 5, you get 1 5, which is 15. Now mapping 2, writing out the primary number 0, 1, 2, 3, 4, 5. Mapping 2, you map 2 to 0, you get 2 0, which is 20. Map 2 to 1, you get 2 1, which is 21. Map 2 to 2, you get 2 2, which is 22. You map 2 to 3, you get 2 3, which is 23. Map 2 to 4, you get 2 4, which is 24. And then you map 2 to 5, which you get 2 5. Now, if you continue to map, mapping 3, we will get 30 to 35. Mapping 4, we will get 40 to 45. Mapping 5, we will get 50 to 55. Now, you will realize that in base 6, the numbers 6, 7, 8, and 9 does not exist. So what do? It means that our primary mapping ends at what? 5. Which means the next number after 5, we have 0, 1, 2, 3, 4, 5. The next number after 5 is what? 10. So the next number we are mapping will be what? 10. So we are mapping 10. So we have 0, 1, 2, 3, 4, 5. Mapping 10. You map 10 to 0, you get 10 0. You map 10 to 1, you get 10 1, which is 1 and 1. You map 10 to 2, you get 10 2. You map 10 to 3, you get 10 3. You map 10 to 4, you get 10 4. And when you map 10 to 5, you get 10 5. So let's assume that our natural number base now is not base 10, but base 6. How will our number counting look like? Our counting number will look like 1, 2, 3, 4, 5, 10, 11, 12, 13, 14, 15, 20, 21, 22, 23, 24, 25, 30, 31, 32, 33, 34, 35, 40, 41, 42, 43, 44, 45. Continue like that. 100, 101, 102, 103, 104, 105, 110, 111, 112, 113, 114, 115, and so on and so forth. Now, if you repeat this for every other base system, base numbers, you will get the numbers that existed in that number base system. Thank you for joining class today. I will see you in the next class. Thank you.